In this video, we'll derive a beautiful formula for the sum of the squares of the first n natural numbers. We begin with this clever algebraic identity. The cube of k plus 1 minus the cube of k equals 3k squared plus 3k plus 1. Now, let's take the sum of both sides of this identity from k equals 1 to n. The left side simplifies as a telescoping sum. We expand this to show how the cubes cancel out in sequence. And all the middle terms cancel out, leaving us with just the last cube minus the first. Expanding this expression gives us n cubed plus 3n squared plus 3n. Now let's look back at the right-hand side of the original equation. We break this sum into three separate parts. We already know formulas for the sum of the first n natural numbers and for summing the constant one, which gives us n. Let's plug those known formulas into our equation. Now we isolate the term we're interested in, the sum of k squared. Finally, simplifying this expression gives us the formula we set out to prove. This identity is not only elegant, but also incredibly useful in both math competitions and computer science. If you enjoyed this visual proof, don't forget to like and subscribe for more math videos.